everyone and welcome to my YouTube channel. Here's a brief introduction about myself. I am a BTech graduate and these are the subjects that I teach. So if you would like to connect with me for a one-on-one or a group session, please check out the description below. So in this particular video, I will be taking up some of the questions from trigonometry that had been asked in the previous year questions under ICSE. Before moving on with our first question, I would like to just give you a glimpse of trigonometry as to what are the basic things that we must know before doing any such type of questions. So as per trigonometry, we know that there are different types of trigonometric ratios. The first one is our sine theta, which can be written as perpendicular upon hypotenuse. Then there is cos theta, which can be written as base upon hypotenuse. Then there is tan theta, which can be written as perpendicular upon base. Then there are some of trigonometric ratios which are just the reciprocal of one another. If we move on with cosec theta, so we can write this as hypotenuse upon perpendicular, and this is just the reverse of sine theta. Then moving on with sec theta, it can be written as hypotenuse upon base, and it is just the reciprocal of cos theta. And then for cot theta, it is simply base upon perpendicular, and it is the reciprocal of tan theta. Then there are three particular portion or rule that we must remember to solve any of the proving questions from trigonometry. The first one is that sine square theta plus cos square theta is equal to 1. The second one is 1 plus tan square theta is equals to sec square theta, and the third one is 1 plus cot square theta is equals to cosec square theta. So now let us move on to our first question, and in this particular question they have asked us to prove the identity, and in our left hand side it is given to us that sec a minus 1 divided by sec a plus 1. We have to prove that this particular portion is equal to this part. So it is better that we convert this sec into cos. How? This is just the reciprocal of it. So I can write 1 by cos a minus 1 whole divided by 1 by cos a plus 1. The next thing we can do over here is that take the LCM in both numerator and denominator. So I will be getting 1 minus cos A whole divided by 1 plus cos A if taken cos A as the denominator. Now we can clearly see that this cos A and cos A will get deducted from each other. So we have 1 minus cos A divided by 1 plus cos A as our final result, which is just equivalent or equal to right hand side. So therefore left hand side is equal to right hand side over here. So we can say that this particular portion is proved. Now moving on with our second question, it is given to us that sine A upon 1 plus cos A is equal to cos A minus cot A. So in our left hand side, we can say that sine A by 1 plus cos A. So the better thing is to do that we can use the concept of rationalization over here. That is multiplying the numerator and denominator by 1 minus cos A. So when we do this thing, in our next step, we will be having sine A multiplied with 1 minus cos A divided by This is a plus b, this is a minus b, so it will be simply a square minus b square. So this will be 1 minus cos square a. The next thing that we can do over here is that we can open the bracket in our numerator. So this will be sine a minus sine a cos a. Then we all know from our relation that we just studied in our first slide is that sine square a or sine square theta plus cos square a or cos square theta is simply equal to 1. So in place of 1, I can substitute this value. So I can write that sine square a plus cos square a and minus cos square a. So over here cos square a minus cos square a will get deducted from each other. So in our next step we will be having sine a minus sine a upon cos a divided by sine square a. What we can do is that we can split this sine square a to both sides. That is sine a divided by sine square a minus sine a cos a divided by sine square a. So this is simply sine a sine a is left over here, sine a and sine a. So 1 upon sine a is simply cosec a and cos upon sine. So this is important to us that there is another relation that tan theta can be written as sine theta upon cos theta. So if I am writing cot theta, it is simply the reversal of or reciprocal of tan. So this can also be written as cos theta upon sine theta. So in place of cos a minus sine a, I can write cot a, which is equals to our right hand side, and this is how we can prove this particular question. Moving on with another interesting question, and we have cosec a minus sine a whole thing multiplied with sec a minus cos a and whole thing multiplied with sec square a. So in this type of question, one thing that we can do is to convert cosec a, sec a all in the terms of sine and cos. So my left hand side is cosec a minus sine a, then sec a minus cos a and sec square a. So in our next statement we can write 1 upon sine a minus sine a, then there will be 1 upon cos a minus cos a, and this will be 1 upon cos square a. What we can do is that we can take the LCM over here. So this will be 1 minus sine square a divided by sine a, then multiplying it with 1 minus cos square a divided by cos a, and then 1 upon cos square a. So now we can make use of sine square theta plus cos square theta is equals to 1. What we can do over here, if I'm pushing this sine square theta over here, what remains is cos square theta. So in the next step, I can write that cos square a divided by sine a, then multiplying it with, if I'm moving this cos square theta on the right hand side, I will be left with sine square theta. So I can write sine square a divided by cos a, and this one as it is. Since everything is in multiplication, we can cancel out sine a with a sine, cos square a with a cos square a. All we are left is with sine a upon cos a, which is simply tan a, which is our right hand side. And this is how we can prove this particular question. Moving on with yet another interesting question, and what we have is tan square theta divided by sec theta minus 1 whole square, and we need to prove it with 1 plus cos theta upon 1 minus cos theta. So let us write the left hand side. Then we have tan square theta whole divided by sec theta minus 1 whole square. Since I need cos part, what I can do, I can make use of the second identity, that is 1 plus tan square theta was equal to sec square theta. So what I can do, I can write tan square theta as sec square theta minus 1. So in place of this, I can write sec square theta minus 1 whole divided by sec theta minus 1 whole square. As we can clearly see that this particular portion, which is our numerator, is in the form of a square minus b square, which can be simply written as in the form of a plus b and a minus b. So simply I will be converting this into that part. So I can write this as sec theta plus 1 multiplied with sec theta minus 1, and this whole thing divided by sec theta minus 1 whole square. Now what I can do, I can deduct this part from this one. So all I am left with is sec theta plus 1 divided by sec theta minus 1. What I can do, I can now convert this into cos. So this will be 1 by cos theta plus 1 whole divided by 1 by cos theta minus 1. Let us take the LCM. So at the numerator, this will be cos theta 1 plus cos theta, and in the denominator this will be again cos theta, and this will be 1 minus cos theta. This cos theta gets cancelled out. What I am left with is simply 1 plus cos theta divided by 1 minus cos theta. This is our right hand side. Now let us move on to the next question, and in this particular question, the only thing which can make any difference is this square root portion. What I have to do is, in this particular question, I have to just nullify this square root which is already there in the question. And what I can see is that there is 1 plus cos A in the denominator, and the proof also need 1 plus cos A. So whenever you see these type of questions, the only thing that will help you to nullify the square root is do the rationalization. But in this particular question, I will be making use of rationalization, but since I need 1 plus cos A in the denominator, I won't be using the standard technique of rationalization. That is, if something is there in the denominator, I have to use the opposite thing. I won't be using that concept over here. So if I am moving on with this particular question, according to the question, it is given to us that square root of 1 minus cos A divided by 1 plus cos A. So what I can do is I will be multiplying this thing by 1 plus cos A divided by 1 plus cos A, since I need 1 plus cos A in our denominator. So in the next step, I can clearly see that the upper portion contains a minus b and a plus b. So this can be written as a square minus b square. And this can be written as simply 1 plus cos a whole square, since this thing is repeating 2 times. Now again, sine square theta plus cos square theta is equals to 1. So I can simply write sine square theta in place of 1 minus cos square theta. So in the next place, I can just simply write sine square a and divided by 1 plus cos a whole square. Now make use of square root. Square root of a square will be simply the square will be deducted. So this will be simply sine A divided by 1 plus cos A. As simple as that. Moving on to our last question of this particular video, I will be um, making out some more questions in our next video. But for this particular video, this will be our last question. And this is one of the interesting question because in our denominator there contains tan and cot, but in the right hand side I just need simply cos and sine. So in this particular question, the only technique which you will be using is that try to make use of cot and tan in terms of sine and cos. What do I mean by that? Is that try to convert tan and cot in respect to sine and cos. So what I can do over here is that when I am starting with left hand side, it is given to us that sine theta whole divided by 1 minus cot theta plus again a fraction that is cos theta divided by 1 minus tan theta. So in the next step, what I can do is that I can convert this cot into cos upon sine, because tan theta is what? Sine theta upon cos theta, and cot theta is the reversal or the reciprocal of tan. What I can do, I can write over here sine theta upon cos theta. In our next step, try to take sine theta as the LCM in the denominator. So this thing becomes as sine theta minus cos theta, the whole thing divided by sine theta. Remember that this sine theta is the part of the denominator only. Then a plus sign cos theta divided by cos theta and minus sine theta divided by cos theta. What will take place over here, that this sine will go above and this cos will go above, making them a square. So in the next line we can write this as sine square theta divided by sine theta minus cos theta plus cos square theta divided by cos theta minus sine theta. Now what we have to do over here is that I need sine theta plus cos theta or cos theta plus sine theta. What I can do is that I can see that somewhat the denominator are similar. The only difference is that in the left one fraction sine is positive, in the right one fraction cos is positive. What I can do over here is that I can take minus sine as common. That is, let it be sine theta minus cos theta, but over here I can make use of that. Like if I'm taking minus sign common over here, this that sign will become positive and this cos will become negative. Now this minus and plus when multiplied will change into minus sign. So this will be sine square theta divided by sine theta minus cos theta and a minus sign cos square theta by sine theta minus cos theta. Since the LCM are common over here, I can simply write sine square theta minus cos square theta divided by sine theta minus cos theta. But I don't need this denominator, and I can clearly see that my numerator is in the form of a square minus b square. I can convert this as sine theta plus cos theta multiplied with sine theta and minus cos theta whole divided by sine theta minus cos theta. Since these two are equal, they get deduced from here. What we are left with is sine theta plus cos theta, which is similar to cos theta plus sine theta, and this is our right hand side. So these were some of the interesting questions which were asked in the previous years of ICSE examination. I hope you did like this video. Do comment, share and subscribe to my channel, and also share it with your friends and families. See you in the next video.